introduction. I'm Venkat Kolli. I'm the product manager for a product that we have in Sandisk that's focused on Ceph. So I'm not going to be talking a lot of the product. So you have Simon, if you have any questions on the product that later you want to get to know more about. So we'll be able to happily to answer on that. So Sandisk, as Andrew was mentioning before, we started on the journey with Ceph about 2.5 years ago as an all-flash storage system solution provider, primarily focusing on Ceph and OpenStack. So what I'm going to be walking you through is the journey that we have taken this past 2.5 years and what we really have done. So Sandisk's primary focus on Ceph is on the performance, is to really unleash the performance of Ceph, especially when you put it on all-flash storage. And as we talk to the community, and as you see it, part of the community discussions, you will notice that there's actually a lot of interest that's growing on how Ceph could take advantage of an all-flash solution, all SSD solution. So it's a very growing interest in the community, and this is something that we are very proud for us to be involved very early on, and go and being part of it. So very just quickly, so that some legal stuff about this thing, and you can read it offline. Just to get the context of what is that we are doing, right, and what is that we are selling. So this is an all-flash storage system, and I'll give you a little bit more details in the context of Ceph, what it does and how you could use it with Ceph. But this is basically a system that we designed primarily for OpenStack and Ceph-based deployments, right? The use cases that we designed this for is primarily for a very large capacity workloads, be it big data, large containers, storage containers. Typically, when you see as an all-flash storage system, you tend to see it in a small capacity for a very limited capacity, but a very high performance. But that's not where we are addressing, and that's not where we are with our flash. We are really going after a very large capacity systems, like scale-out systems, like Ceph, right? Where typically it's deployed on hard drives, but we think we have a cost point, and we're able to bring the cost to be competitive enough to offer the flash advantages for these large capacity workloads. So these are the big data, large media repositories, et cetera, is what we really have designed the system for. So again, giving a very brief specs and overview of the system before we actually go talk about the Ceph and how the Ceph works with flash, right? So this InfiniFlash is the system. So we're able to pack in 512 terabytes of flash in a 3U chassis, right? It's a very high dense and a very large capacity. You don't necessarily need to use it with all 512 terabytes, and especially when you use it in a scale-out cluster, typically most customers don't pack it up as a full capacity as a single node, because you're going to be scaling out, so you can start off with the smaller capacities for each InfiniFlash node and scale out. At the same time, there are customers who are looking this for multi-petabyte deployments. So in that case, the density in a 3U, the 512 terabytes in a 3U becomes critical for them. So that's what, this is what it is designed for them. And the way we achieve that is with these cards. These are not SSDs. These are specially designed cards specifically to achieve that scalability and the density, right? And it is a SAS-based flash. You can see that there's a huge capacitor bank at the bottom that gives you the power fail capabilities of so it have the full enterprise SAS based capabilities with this. The one thing that we purposefully designed this is to not include the servers in it, not include the compute in it. The reason for that is we want to make it a more disaggregated solution, and primarily that is important for Ceph. Is because Ceph could be used for multiple workloads, right, and different types of objects or different types of data, be it object data, block data, or in the future file data, right? So we want to make sure the solution is flexible enough by adding in the right set of compute to it, rather than designing a certain set of amount of compute inside the box, we want to make sure that it is flexible enough that you could bring in the right amount of compute and make it usable for this, optimized for different types of data, right? So we purposefully eliminated the the compute out of this, but you can connect the servers through 8 SAS ports that comes out of the box. So you can have multiple different combinations of the servers up till 8 to be connected to this box. At the raw box level, and this is not the Ceph performance, and we're going to go into the Ceph performance in a lot more detail soon. But at the box level, we're able to get about 1 million IOPS, right? Around 4K random. And the throughput is between 6 to 9 gigabytes. This is based on the current 6 gigabyte backplane that we have. And soon, in a couple of weeks, we're going to be upgrading that to 12 gig. Then you can get the performance almost doubling it. Now, please remember these numbers, and you'll see when we talk about Ceph, right, how they relate to the performance that we are able to get at the raw box, right? We optimize Ceph, and in fact, Ceph was optimized that it's almost getting a full raw performance out of it, and that is quite interesting, right? Given the capabilities of Ceph, right, all the features and everything, and still is able to fully optimize the box is quite remarkable, and that's something that we're just very proud to be involved in making the Ceph quite efficient that way, right? And just very quickly from the availability standpoint, but this comes up all the time because when you have these large systems, what the data availability is. Flash obviously is a lot more reliable than the hard drives, but also every single component in this box is completely hot swappable, and you can have it in this fully redundant. You see that 4 fan drives, N+2 configuration at the back. You can't see it here. But again, you have multiple redundancy failure in here. And the MTBF, the failure mean time between failure is about 1.5 million hours. This is quite high. Again, it's just because it's an all-flash solution. So that's basically what the InfiniFlash system is, right? So coming to what we have done with Ceph. So again, we sell this as a solution with Ceph, right? So we have it fully optimized and tuned Ceph configurations that comes with the system. And again, one thing that we want to really note and emphasize is Sandisk, from its very early on, has been committed to the open source, right? Anything that we do with Ceph is 100% committed back to open source. So we use the open source Ceph. We're not making any proprietary branches or any proprietary extensions of Ceph. So everything in what you'll run on InfiniFlash is the open source Ceph. And it's a good thing that we make our living selling the boxes, not the software. So we don't have to go do this thing. So we are fully, from very early on, we are fully committed to the open source principles of Ceph, and we'll continue to do that, right? So just quickly, as I mentioned before, so we started this journey around in summer of 2013 with the dumpling release. And so when we started building this box, all right, and when we quickly decided Ceph to be the system for us to power this InfiniFlash, one thing to our shock, we found out that the performance that we were able to get with Ceph on InfiniFlash at the time was really not that much different than the hard drives. Imagine our surprise. So we are, proud of this, big, huge all-flash system, and it's doing no better than a hard drive system, right? So I think at the time we were able to get about 10 to 15K IOPS with the SSD journals and hard drives, and even when you put that in an all-flash solution with similar configuration, it's really not that much different. So one thing that we quickly realized that there's a lot of optimization that is required within Ceph, and also a lot of tuning with the hardware is required, right? Because most of the deployments we've seen at the time, and most of the experience in the community at the time is having the Ceph optimized for hard drives, not for an all-flash. Yes, SSDs have been used for journals from very early on, but having it as an all-flash solution, no one has started doing that when we started looking at it. So we quickly determined that it's really the OSDs are getting the bottleneck here. And by the way, I know some of you are new to Ceph, so some of the terms that we'll be using here are, and if you're unfamiliar with this, please feel free to stop us. But mostly, these are the talks that generally are oriented to the community that the people, the users of Ceph today, right? So if there's anything that we need to slow down and clarify, please do stop us. So one thing that when we started this is that the OSD is turning out to be the bottleneck here, right? So it's we were able to get about 1,000 IOPS around that time. And that's using about around 4.5 cores per OSD. And so we thought about and thought, okay, should we be using more OSDs per SSD, right? Or in our case, that flash card. Remember, our flash card is 8 terabytes, so it's a huge capacity card that we have, right? So we thought about using more OSDs, but we quickly moved away from that idea. Not just because it is not optimal, but having the failure domain or the crushed rules, managing crushed rules is going to be a nightmare. You will not like it, and it is going to be very hard to manage. So, in the interest of the the usability and the manageability of the solution, we quickly moved away from that idea. So we started working on enhancing the data path, primarily focused on the reads around the time. So when we started this. We thought that there's a lot of room for improvement, and especially that's more impactful on the reads. And I'll actually talk about in the roadmap what we are doing now with the writes, right? So the data that we have today, and which I'm going to show the numbers, are primarily with these changes without the write changes yet, right? The write changes are going to go into Jewel with the upcoming release. So on the read side, what we found out is that there's a lot of context switching happens in Ceph. And that did not matter much when you're using in the hard drive because the latencies of hard drives are pretty high. So no matter how much context switching is happening, it didn't matter. But when you put it on a low latency media like flash, that becomes very expensive, right? So we kind of took a lot of queuing optimization, right? And we removed a lot of lock contentions, right? So we make the locking more granular. So you can actually we speed up a lot of these things. So doing a lot of lock optimization and queuing optimization really made a lot of difference within Ceph. And the other aspects is the socket handling, right? So there are too many, getting the small I/O requests going into the kernel. That's something that we have eliminated, right? And we quickly disabled the Nagel's algorithm inside the Ceph. And primarily that made a lot of difference from the latency standpoint. There are many other things. There are a whole bunch of things that have been done to get to the performance, which I'm going to talk about in a few minutes. Primarily just enhancing the cache lookups, right? And anything regarding handling the copy mechanisms, right? So there are many minor things that went in that really made quite a bit of a difference. And the net result is that so with the current testing that we are done, right, which is currently we are testing it on Hammer, we are able to get to over 80K IOPS per OSD. Remember, this is when we started this, about 1,000 IOPS is where we were. The more interesting thing is really the looking at the CPU usage, right? Even at 1,000 IOPS, at the time when we started it, we started consuming over 4.5 cores or so. Now we just doubled the core consumption, but for the amount of the work that we're doing, right, it's become very, very optimal. In terms of the CPU usage as well. And this is one thing that you'll find, and when you see the performance numbers coming with the flash, the one thing that you'll quickly realize is that now CPU matters a lot. Because with the flash, you completely remove the bottlenecks from the storage media, and all of that bubbles up. Now it's actually the CPU, and especially with the small blocks, especially if you're going to be using like the OpenStack workloads, which is at the 4K writes or 4K IOs. This is the CPU matters a lot, and I'll show you a couple of numbers that shows you how much difference the CPU counts. I'm pretty sure that makes Intel very happy. All right, so most of these changes have been, the read performance changes have been through these releases. Most of them are in Giant. So anything that obviously Hammer inherited all the Giant release. So anything that if you're going to be using Hammer, you will see the same performance coming out of the threads. Again, when you deploy it in all flash. So quickly getting to the numbers. So talking about the system itself, the one that we used. So the one thing that we wanted to really compare is to kind of see how the Ceph would perform, right, without any tuning and with all the tuning and all the changes that you've done for Flash, right? So we used in this test configuration, we used one InfiniFlash. IF100 is our number for the InfiniFlash system. So this is a 512 terabyte system, a fully populated system, and we used 2 OST nodes. These are the dual sockets, 12 core each, so 24 physical cores for each OST node, and 4 block drivers, 4 RBD clients running this, right, and using a 40 gig switch. A little more details on this. Again, just if you want to know the configuration that's used for this particular test, so you have this for your reference, right? So very quickly, so this is a test that we've done with the Giant. This is a very first release that with all the changes that I mentioned in the previous slide, a couple of slides ago, right? This is the net result of what we're able to get, right? Now, to compare this, again, there's a lot of data in here, but let me just quickly walk through what it is. So this is done for an 8K random read IO workload, right? What we're really comparing between the red bars and the blue bars really are essentially if you take the Ceph as it is without any sort of tuning and without making any changes with just the defaults and using the same hardware. So both those tests are run on InfiniFlash. One is without any tuning, right? And the other is essentially with the complete tuning and with all the changes that went in, right? So if you look into on the read side, right? So the blue bars is basically what it is with any sort of tuning on all flash, and the red bar that you see there is about 250K IOPS compared to about 10 to 15K IOPS. So the net lesson that I want to take you away from is tuning matters a lot for Ceph, for the particular hard drive, for the particular hardware, right? And that's especially true with a high-performance system like Flash, right? So you really need to figure out how exactly, and I'll talk about some of the tuning parameters that we used and that made a lot of difference here. But essentially, having the Ceph tuned for the particular hardware that you're using makes a huge amount of difference, tremendous amount of difference. And I don't think this is going to be the true with the current release, with the Hammer release, because with the Hammer, there's a lot of changes that went into the defaults as well. That really is not going to be this dramatic, but it still is going to be highly impactful, right? So that's something that you would have to consider. And the same thing with the latency as well. The multiple the bars that you're seeing is for different queue depths, right? So, and obviously using an all-flash system like InfiniFlash, a large high-performance system, you get a much better results with the higher queue depths, right? From the IOPS standpoint. That might not be true with the latency, but from the IOPS standpoint, if you're going for the maximum IOPS, you got to have the highest queue depth as possible. Here we are using about 16 queue depths. Okay. So very quickly, the other thing that I really want to show as a showcase test is that, so how does it behave as a cluster? How does the performance scale when you put it on multiple InfiniFlash nodes, right? So in this case, we are taking the same capacity, right? The 512 terabyte capacity that I showed you earlier. Now we split this into different nodes in a cluster, right? Because after all, at the end of the day, this is a scale-out cluster, right? So you'd want to basically grow as grow as scaling out, right? By adding more nodes. So what we did is that each of these InfiniFlash nodes now holds a quarter of the capacity. So each of them holds 128 terabytes, right? And so now we have 2 OSD nodes, same as before. We're using the same servers. So the key difference now you need to note is that, so in the previous case, you have a full capacity, 512 terabyte, right, running with the 2 OSD nodes and running with a few RBD nodes, right, 4 clients per InfiniFlash system. Now you actually have 6 OSD nodes powering this cluster, right? So at the end, it's basically 385 terabytes, around 385 terabytes, the total capacity of this cluster, with 6 OSD nodes and running about 5 gateway nodes, right? So that's and the same configuration and the same type of servers running this. Now, if you look at the performance that you get out of it, I mean, running the same 4K blocks, right? So we are now getting almost 900K IOPS on a 385 terabyte capacity cluster, right? So if you note that million IOPS at the raw box level, we're almost there running Ceph, right? Getting the performance out of it. However, I mean, the big difference really is that we kind of spread that out into different InfiniFlash nodes, right? The same capacity rather than measuring it on a single box. With that difference, but still, if you look at per terabyte performance, right? So you actually, with Ceph, you can actually get to almost 1 million IOPS with 385 terabyte flash system, right? So that's basically the net of what with all the optimizations and all the changes that went into the Ceph and how it's able to perform. Okay. So just a couple of other points. Again, it's from the latency standpoint, we are averaging around 2 milliseconds of latency with Ceph, right, at the 4K blocks. And if you look for 2 nines consistency latency, it's around 10 milliseconds. Right, 3 nines is about 20 milliseconds. 2 nines is around 10 milliseconds. One is obviously, as I mentioned before, if you're working on a small block workload, CPU makes a huge amount of difference. So in this notice, I mean, if you have we are still CPU bound at the 4K blocks, right? So if you increase the number of cores or number of servers that's powering this, you'll actually get higher, there are much more improvement for IOPS, number of IOPS in this solution, right? But obviously, as you get to the larger block, CPU doesn't matter much. Now it's the bandwidth, it's the network that's really going to be the critical. So we are testing this to the 40 gig, and that's where, so as you get to anywhere from 64K block workload, anything higher than that, you really 40 gig almost becomes a requirement for this kind of solution, right? So, or else you really will be severely constrained at the network level. So we have a lot of customers that deploy 10K, 10 gig. And again, we're going to talk about the network in the next session. But one thing that you'll notice is that for most typical workloads and you're using a high performance media like flash, network needs to be sized properly, and 40 gig is going to be getting a critical requirement once you reach a certain capacity. Okay. So moving on from the reads to writes. So one thing, if you kind of notice, and I kind of quickly glanced over in the previous slides, is if you look at the writes are still a major issue with Ceph, right? And that's what we are working on right now. And there are many changes that we went through. And so one thing that we quickly figured out is that again, the writes, just as with the reads, are primarily are designed for hard drives, and so the journals are used for are used as a mechanism to address the latency issues, right? But one of the things that really happens is that there's a lot of batch processing happening in the background, right? That still is a big constraint for the write performance. So this is still, so for the flash, when you put it in all flash, right, that becomes a major issue. So we saw a lot of spikiness even when we used some kind of low performance. First, what we tried out is that we tried to use the NVRAM, front-ending the flash, right? So to kind of make the journals even more efficient, right? So typically the strategy is that you put the data on hard drives and you put the journals on flash, on SSD, right? So we took that next step of putting the data on the flash and putting the journals on an NVRAM. The one thing that we found is that there is obviously some improvement there, but there's a lot of spikiness that happens because of that the big batch processing that happens at the back end, right? So you don't have any consistent performance. And for most of you who have been running storage systems for long, inconsistent performance is worse than not having even an average performance. Is worse than a bad performance, consistent bad performance. Most customers and most of your workloads, I'm pretty sure, would prefer to have some kind of consistent performance, even as bad as it is, right, than having something that's very spiky and unpredictable, right? So that's quickly, went out of the way. So we went to basically work on primarily to eliminate this kind of heavy batch workload. So we modified the buffer writing. Primarily, again, this primarily will benefit the flash, right? But most of the things that we went and kind of figured out how to handle those buffer writes. All of these changes are in dual release right now. And so in our early testing, what we found out is that we are about 2.5 times purely on the writes more than Hammer, what Hammer is getting. Right, so when you see the release with Duo, again, this is with all flash, by the way, so most of these things would not matter much when you deploy it on hard drives. But when you deploy it on all flash, you will see with the upcoming Duo release on the writes, this is going to be about 2.5 times of where we are with the Hammer. The latency is also cut to half of it. Okay. So there are a few other things quickly. What we are doing is we are working with Mellanox very closely on the RDMA. So there's a significant reduction in CPU, even further than what we are seeing out there. Remember, as I said before, CPU becomes the critical factor when you put it on all flash. So it becomes the key for us to have some of these techniques with like RDMA to minimize the contention. And we're working really closely with the new backend store, the new store, and then to make the more optimizations for that. So we have Sandisk has developed a key value store that's primarily for any open source system running on an all flash. It's a very highly optimized all flash key value store for an all flash system. Right, so there's something that we are now open sourcing it and making it part of the backend of the Ceph as well. Right, so the new store is now we're planning to have this new key value system, key value pair to be used as a backend. One of the key things also that makes a huge amount of difference, although it is not quite part of the Ceph code, is the memory allocation of the underlying OS. Right, so the TC malloc, JE malloc, and async messenger. So these are some of the key tunables that I mentioned earlier makes a huge amount of difference. So right now, most of these changes that we are manually doing, right? So and that makes a difference of almost a 3x of the improvements. So one of the things that we going to be doing is that we'll be working with the other Ceph providers. We primarily partner with Red Hat as one of our premier Ceph provider. And we kind of make those as the defaults and and make it available as a tuning scripts. So when you're deploying it, it becomes easy, and so you don't have to manually do these things. Okay. So very quickly, so what we do with Ceph, again, and I mentioned, so our key focus really is with Ceph is to get the performance, highly tuned and highly optimized performance for all flash, but also make it a lot more usable when you deploy it on a large-scale system like InfiniFlash, right? So it basically starts off with an open source Ceph, and with all the changes that we've done, again, part of the open source of the community Ceph, right? So with the open source and the Sandisk enhancements, there are a whole bunch of things that we built around it, primarily for make the installation easier, Patrick talked about Ceph Deploy and the other new provisioning tools. So we are going to be working with the new provisioning tools. Currently, our installation is based on Ceph Deploy. It's a modified Ceph Deploy, enhanced Ceph Deploy tool that is specifically tuned for InfiniFlash. So, I mean, the key thing is that our goal really, just as any other systems vendor out there, is to make Ceph more consumable and more easier, right? Getting Ceph more to beyond the smarter folks like you who can handle this by yourself. But most of the system administrators out there are nearly not as capable, and that's one thing that scares them heavily, right? When you look into Ceph, as powerful as it is, to make it easily digestible and easily consumable is a key part of our strategy, and that's true with Red Hat or pretty much all the other Ceph providers that are out there, right? So there are things that we are doing, many things that we are doing. I'm not going to walk through all of this, but primarily on the usability side and on the planning side, right? How you actually get the right configuration. Remember, the configuration matters a lot. A tuned configuration matters a lot in performance. So how do you get this out of the box using InfiniFlash? And lastly, on the supportability aspect, so there's a lot more log collection diagnostics built into the Ceph on InfiniFlash, right? So that's basically where Sandisk is primarily focused on. Performance along with the usability. Performance is all open source, is all the code that's into the open source, and usability is something that we are focused on around the hardware. Okay. So so we have a huge amount of team and resources that have been invested in Ceph for a long time. Our team is about over 25 engineers that is focused on Ceph, purely on Ceph, right? And half of that is primarily working on the performance enhancements that I mentioned earlier, and the other half really is in the amount of heavy testing that we do, obviously for InfiniFlash. Again, one of the early vendors of the all-flash system, right? So one of the things that we have to go do is to really enhance the Tithology test suite to make it more relevant for an all-flash system. So we did quite a bit of work and a lot of contributions that happened from Sandisk on this automated Tithology test suite as well, right? And we still continue to do that. And so there's a very heavy amount of testing that we do. And you see some of the numbers there in terms of the hardening, in terms of scale testing, and in terms of the failure testing, right? So this is, again, just to make it more enterprise ready, and for the customers, who just are, want to have a more assured solution with the hardware and software combined. So that's basically what we are going and what we're going to be providing, right? One of the other key difference with InfiniFlash compared to what you see out there in terms of Ceph deployment, the way InfiniFlash differs slightly, because typically when the Ceph is deployed, it's deployed on a converged node, right? So where you have the hard drives attached within a CPU complex, right, within a node, and you scale with those nodes. So you have the CPU and the drive and the storage, kind of more or less in a fixed ratio, right? And it's much easy to deploy because you just need to replicate with the nodes, and Ceph can take care of all the balancing and everything coming out of that hardware. One thing with the difference with InfiniFlash is the amount of disaggregation that happens between the storage heads and the storage clients, right? And the key thing that's key for us, because when we look into this multi-petabyte deployments, that's where the solution is primarily geared towards right? One of the things that we find with our customers, and again, our experience comes from selling this to large hyperscale customers, huge social media companies, large e-commerce companies, mostly US-based, right? For them, the key thing is that at a very large scale, all these customers are moving away from these hyper-converged nodes. Because one thing that they find is these converged nodes are gets to be quickly unbalanced based on their workload characteristics, right? Obviously, so when you need more processing power, right, you have to add in more nodes, adding more capacity to it, even if you're not going to be using that capacity, and vice versa. Sometimes when you have change your replication policy to add more protection, right? So you need a lot more capacity, but you don't need all the processing power that goes with it. And at a very large scale, that becomes expensive to use the processing or to use those resources that you're not using. So for them, it is very important for them to tune the configuration very specifically to the amount of compute that they need and the amount of storage that they need and the amount of network that they need, right? As a quick example, if you're running a small block workload, a 4K block workload, you need a lot more CPU processing, right? So here you could just add more OSD nodes without having to add more InfiniFlash storage, right? So you can address the small block workload within that cluster by adding more CPU nodes, by adding more OSD nodes, right? And vice versa, if you're basically be using it for a large object, right, like 64K object or 1 meg object, you don't need much CPU. So you can actually downgrade your servers to a single socket servers and probably use even a single OSD node, but actually connect that to a 40 gig network, right? So within the same cluster, it is now possible for you to tune your system to the right amount of workload that you're basically running on. And if you think about it, most of the clusters that are built out today is built in a OpenStack environment where they're building it for private clouds. A lot of the enterprises are building it for private clouds. And when you're building it for a private cloud, you're not optimizing it for any single workload, right? Your goal really is to make it as a universal infrastructure that you actually can have multiple workloads coexisting in it. So it is very important for your cluster to be balanced and to be able to tune and handle the different types of workloads. And that's where this disaggregation becomes very critical for them, right? So that's one of the reasons why we specifically, by design, eliminated not having the CPU and everything built into the storage, right? So that it could be balanced right way. Okay, so very quickly, I'm just going to skip through in the interest of time. So there are different ways our customers deploy InfiniFlash in obviously an all-flash solution. And again, you can talk to Simon on what the price points that is available as, and you'll be very surprised at how fast the cost of flash is coming down. And more importantly, it's also not just the cost of dollar per gig on flash, but it's also some of the techniques like this, like where you disaggregate and you look into the overall system costs, including the OpEx and the CapEx, everything. You will be actually very surprised, just like our largest customers are finding it to be much cheaper than the hard drives for the performance that you're getting. So the other ways that some of our customers are deploying it is with the combination of hard drives, right? So this is not a typical way, this is not based on the typical caching that Ceph provides, but this is more about the tiered solutions. And there are some things that we are doing within the Ceph as well to increase that tiering, persistent data tiering within Ceph. So taking the Ceph caching and make it a lot, Ceph caching policies and make it a little bit more robust for having it as a persistent data tiers. And so this is, again, one of our customers. They're using it to be having a low activity data on a hard drives, and there are backend behind InfiniFlash, right? So that's one way to be using it with the hard drives. And there's one customer that's actually trying this out as keeping the primary copy on flash and keeping the secondaries on the hard drives. And you can have the higher affinity set to the primary copy, so most of your reads keep happening just on the primary copy, right? So because you have a lot of bandwidth coming out of this, so they're completely fine with that. Obviously, your writes are going to be limited to what the hard drive can handle. But even there, if you're able to eliminate the reads from the hard drives and just keep the hard drives only as just going the writes going there. Now it's just doing a sequential writes, and hard drives can handle just the sequential writes fairly well, right? So if it's just doing one thing, it can just do okay. So your performance is really not going to be that bad then compared to where you're using a hard drive system for both reads and writes simultaneously, right? So when you just relegate that to just the write for protection, as this customer is doing, right, that also works fairly well for them, right? So this is, again, just as a TCO, as a quick note about where this customer is how measured, and this is the data coming from the customer. They basically are planning a 100 petabyte cluster. So this is going to be one of the largest cluster, Ceph cluster. This is not Yahoo, by the way. This is something that the customer don't want to be don't want to be announced, right? So in the next year and a half, so they plan to go to about 100 petabyte cluster, and they did the TCO analysis on the traditional hard drives, which they were planning to have before before InfiniFlash. And so, based on the commodity hard drives, they are able to measure to be about, around 45 million is what they were budgeted. This is including the 3-year OpEx, right? Basically the acquisition and a 3-year OpEx combined. And they compared with InfiniFlash with different techniques. So one is with the full replicas. Obviously, it's more expensive. The second bar that you see is there is the full replicas, 3 full replicas on the object storage running on InfiniFlash. But the other key thing that's very interesting thing, and which I can talk offline, is erasure coding and how it works with Flash. The one thing that we find with the erasure coding, how many of you are familiar with erasure coding? Good. So that's one thing that Ceph provides as with the full object storage, native erasure coding, and this is what they were planning to use with an all-flash media. So they find to be a very cost competitive, are actually even cheaper compared to the OpEx when you compare the 3-year OpEx, right, with an all-flash erasure coding. And the last one is basically primary on flash and hard drives, which they're not going to, right? But just kind of want to give you a comparison that they did. And the primary factor that is affecting the cost is really at the bottom graphs. It is basically showing the total data center footprint, right? So they were planning to have around 90 racks for this 100 petabyte data based on their earlier hard drive based model. And with the InfiniFlash, with an erasure coding model, which they're going to, right, they are able to get that to 18 racks. From around 95 racks to 18 racks, they eliminated a complete data center build out for this. And that's basically the huge amount of savings. This customer really doesn't care much about performance. For them, performance is not the key criteria. They are quite happy with what they are able to get with the hard drives today. Right? Failure issues are different things. So their experience is that they have 35 hard drive failures per week on the cluster size. And when they compare that to our AFR, which is less than 0.15%, it's going to be one SSD or one card failure per week. So 35 hard drives to one card. And the big difference, again, is not the cost there. Obviously, I mean, it's all covered under warranty. For them, once you have a hard drive failure, for the Ceph to rebalance your cluster, that's going to take them more than a week with the workload that they're having, because they're not balancing that work, they're not optimizing that cluster for rebuilding. It's primarily built for the throughput, higher throughput. So that whole rebalancing of the cluster and the spikiness that comes out of that is a huge issue, right? So that's a big difference as well, besides this cost. So I just want to kind of give you a quick glimpse on how Flash is getting used in the data centers today and the performance that you get to get with the optimized Flash. Yes.
Was the OpEx so low on the fourth option?
So OpEx primarily is one thing that I talked about is that the failure rate and the power savings. If I don't know if I mentioned this with the InfiniFlash, it's about 470 watts of power at a fully populated 512 terabytes. Now, if you can imagine, that's almost equivalent to your single server, your single socket server, what it costs. So the primary OpEx savings are few. One is the power savings, power and cooling, and the whole data center space. And all the labor costs are involved in handling the media failures. So those are the 3 key factors that factored into their OpEx savings with an all-flash.
But the fourth one? Why the fourth one so low? The first 3 make sense.
The fourth one, because they haven't deployed this. So from their modeling, they figured out that if they're going to be using Flash, they're going to be using SMR drives because they're purely there for protection. They're not planning to do any reads or any I/O on that. So they felt that because even if they have failure in those media drives, it really is not going to be much impactful. So they figured that those SMR drives and in the last one is going to be just as a passive writing write devices. So they didn't feel that there's not much OpEx in there. If you need more details, I can cover this in offline discussion on this, but just want to kind of give you a glimpse of how it looks like. Okay. Any questions? Yeah.
In regards to the underlying file systems, what did you use? Is the XFS or?
Yeah. So currently it is balanced. It is currently running on XFS. The one thing that you talked about, that's coming up in our roadmap is as we move to the new store, the new backend that's coming with Ceph, we have this new a key value pair that's optimized for Flash. So we want to kind of have that, and right now we're in the process of making that open source. It's currently a proprietary software from Sandisk. So once we make that open source and once we integrate that with Ceph, so we will be planning to move that. And we hope the whole community will be planning to move to that key value store for Flash.
What about the schedule, the underlying schedule?
So there are a lot of scheduling changes that also went in the current code, primarily that went into the giant release, right? And yes, there will need to be more changes that need to happen once we move to the object store. Yeah.
Venkat, there was an interesting presentation by somebody from Intel, I forgot his name. I think it was a girl, right, in Tokyo, looking at comparing running on all the encode and basically the cost
Yeah.
for an 8-3 ratio.
Yeah. Yeah.
2 or 3 by replication. I guess that's. I didn't notice you've got an EC version here. I didn't see an analysis of that.
Yeah, so again, if you're talking about the OpenStack Summit in Tokyo, so Sandisk did a presentation, Alan Samuels.
That's right.
Yeah, so we did a presentation on just erasure coding of it. I strongly suggest you to go look it up. It's all on the web. And just the gist of it again is the same thing that I was mentioning before. When you use an all-flash storage, your whole erasure coding dynamics changes, right, compared to a hard drive system. One is that with just a 20% overhead, you're able to get in fact much better protection than a full 2-copy or 3-copy, right? Even with the full copies, most of the customers or 100% of our customers are just using it for 2 copies, right, with Flash, because Flash failure rates are much lower. So even when you compare that to a 2-copy solution, right, with the 2 times the overhead, now with just 20% overhead, you're getting much better protection. And the key thing there is that obviously, when you use erasure coding, the big downside to it with the current hard drives is that rebuilding mechanisms, right? So how long would it take to rebuild, and how CPU heavy that is? And that's what the Flash is taking care of and eliminating that, right? So it's actually much more suitable now for the active working data rather than just an archival data. That's typically what erasure coding is currently mostly used for, right? So that's the key difference, really, that makes a huge amount of difference. And obviously today with Ceph, natively only the object store, RGW gateways are the only ones that natively can support the erasure coding, and that's something that we're working on a blueprint to make that also for native blocks as well. Today you can still use erasure coding with the cache tier in front of it, but natively we want to offer that for a native RBD blocks. That's coming up in the roadmap. Okay.
What else in the roadmap were you able to share with us?
So again, the gist of it is that mostly we are focused on the writes that are coming up in the near term for the Jewel release. That's going to be little over Q1 before we're targeting Q1, but I think it's a little bit going to slip beyond Q1. And the next focus area for really is just to drive down the total cost when you deploy it in all flash. I talked one about the erasure coding. The other aspects that we are working on with the community is the compression and dedupe. The one thing with the dedupe is a little bit iffy because again we were not sure for the kinds of workloads that gets deployed on Ceph. Right? We know a lot of all flash vendors out there make a big deal out of dedupe, And in fact, the prices that they quote is with the huge dedupe assumptions is made, 6x to 8x, dedupe savings. We don't go to those, we won't do those shenanigans. Anything that we do is basically per raw device. But one thing that we want to make sure is, does dedupe really effective for the type of workloads that gets deployed on Ceph, right? Right now, we hear from some customers, yes, some of their VMs have a high dedupe affinity. And I kind of want to know more from you as well, right, to see how important is the dedupe and how much your workloads are going to benefit that you're considering for Ceph, going to benefit from dedupe. So dedupe and compression is the other aspects, but our key focus area for us to lower the cost of Ceph deployments on Flash is erasure coding for blocks.
The other thing that we are doing, and this is typical for the Flash industry itself, is going to 3D NAND. You're going to see within 9 to 12 months' time that we're going to double the capacity, so you're going to have a petabyte of Flash in 3U. And NAND pricing is dropping. So what you might buy today, you'll be buying for a hell of a lot less than 12 to 18 months' time. So you're going to see the cost of NAND go down significantly.
Okay, so I'm a little bit over my time. Sorry, but if there are any further questions, again, we are here throughout the day, so we can have a discussion. Thank you.